The question is, the value of limit extends to infinity, x log x by 1 plus x square is. This question is from engineering mathematics, from the topic calculus, subtopic limits, 4 options ABCD given in 2021. The solution is limit extends to infinity, x into log x, natural logarithm x, base logarithm x, divided by 1 plus x square. So, this looks like log infinity is infinity, 1 plus infinity is infinity. So, infinity by infinity form. You can apply L'Hospital rule is equal to limit x tends to infinity, differentiate numerator with respect to x, then denominator with respect to x. Numerator is product of two x terms, apply product rule. V into u dash plus u into v dash, log x into x derivative with respect to x is 1, plus x into log x derivative with respect to x is 1 by x, divided by 1 plus x square derivative is 2x. Since by using L'Hospital's rule, so this is now log x plus 1 divided by 2x, limit x tends to infinity. By direct substitution, if I put x is equal to infinity, again infinity by infinity. So repeat the process of L'Hospital rule is again limit x tends to infinity, differentiate numerator denominator with respect to x, log x derivative 1 by x, constant derivative 0, 2x derivative 2 with respect to x. So this is 1 by 2 into 1 by infinity. 1 by infinity value 0. So the answer is 0. I am doing alternate method. So if it works out, let me check. Given limit can be written as dividing by x square with numerator and denominator can be written as log x by x whole divided by 1 plus x square by x square. That is dividing numerator nr and denominator dr by x square there. You'll be getting this. So this is limit x tends to infinity log x by x divided by limit, that is limit f of x by g of x can be written as limit of x by limit gx. 1 plus x square by x square can be written as 1 by x square plus 1. Now this is a standard limit, that is 0 divided by here 1 by infinity 0 plus 1. This is 0. Since limit tends to infinity, log x by x is equal to 0. Standard limit. Standard. So without L'Hospital rule also we can do. So the answer is 0. Accordingly, the option is B. This is the end of the question. The question is the rank of the matrix 4 by 4 matrix given 5 0 minus 5 0 0 2 0 1 minus 5 0 5 0 0 1 0 2 is 4 options ABCD given. This question is from engineering mathematics from the topic linear algebra, subtopic basics, that is rank. Let us denote this matrix by A. Solution. Reduce into row echelon form. This is the first non-zero element in the first row. Make its down element 0. So we should make R3 element with the help of this R1 0 by row operation. Applying R3 changes to R3 plus R1, which is giving a new equivalent matrix 4 by 4 matrix. R1, R2, R4 remains same. 5 0 minus 5 0. Second row no change. 0 2 0 1. Now third row changes to minus 5 plus 5 0, 0 plus 0 0, 5 plus minus 5 0, 0 plus 0 0. Now fourth row no change, 0 1 0. So generally non-zero rows are in the top of the matrix, 0 rows depending bottom of the matrix. So better to apply R3 interchanges to R4 equivalent to a 4 by 4 matrix as first two rows no change, 5 0 minus 5 0 0 2 0 1 0 1 0 2 0 0 0. So this is the first non-zero element. The second row make its down element 0. That is, we should make R3 element with help of R2 by using row operation. R3 changes to 2 times R3 minus R2 equivalent to another 4 by 4 matrix for which R1, R2, R4 remains same. 5 0 minus 5 0 0 2 0 1. Now 2 into 0 minus 0, that is 0. 2 into 1 minus 2 0. 2 into 0 minus 0 0. 2 into 2 minus 1. 4 minus 1 3. Now this is 4 row zeros. So finally 3 non-zero rows. This is the row echelon form condition. P row echelon form of the given matrix A. So it is better to circle by some other color. So the number of non-zero rows before the first non-zero element in each row is less than number of such zeros in the next rows. Okay. So their rank of the matrix A is equal to number of non-zero rows the last step, that is 3 non-zero rows. So the answer is 3. Accordingly, the option is A. This is the end of the question. The question is, a function is defined in Cartesian coordinate system as f of x comma y is equal to x times e to the power y. The value of the directional derivative of the function in integer at the point 2 comma 0 along the direction of the straight line segment from the point 2 comma 0 to the point half comma 2 e. This question is from engineering mathematics from the topic calculus, subtopic vector calculus, directional derivative. The solution is GATE 2021. So the question is directional derivative, two variables function at the point x value to y value 0 in the direction of the straight line segment from 2 0 half comma 2. So first find del f, grad f. This is the two variables I cap dou f by dou x, partial derivative with respect, plus j cap dou f by dou is equal to partial derivative with respect to x is y constant, x derivative 1, 1 into e power y plus j cap into partial derivative with respect to y is x constant, x into e power y derivative e power y which is y, and substituting at the point 2 comma 0, that is x value 2, y value 0, e power 0 1. So I cap x value 2, e power 0 1 2j. This is step. Okay, before finding step 2, that is we need to find the unit vector in the given direction. What is given direction? Straight line. Okay, so straight line, that is equation straight line joining 2 0, that is x1 y1 and x2 y2 half comma 2D geometry 2 points joining straight line is x minus x1, or you can write y minus y1. This is y1 x1 y1, this is x2 y2. Y minus 0 is equal to slope, that is y2 minus y1 by x2 minus x1, 2 minus 0 by half minus 2 into x minus x1, that is x minus 2. Half minus 2 is minus 3 by 2. So this is minus 4 by 3. You will be getting y is equal to minus 4 by 3 into x. Minus 4 by 3 into minus 2 plus 8 by 3. Looks like mx plus c. Slope intercept form. So m is slope equal to minus 4 by 3. Okay. Usually that slope is also denoted by tan theta. So according to the right angle triangle, this is theta. This is 90 degrees. Opposite side by adjacent side 4 by 3. So Pythagoras theorem, this hypotenuse side is 5. From this cos theta, adjacent side by hypotenuse, that is 3 by 5. Cos theta is equal to 3 by 5. Now, this is here second quadrant. In second quadrant, cos theta is negative, sin theta is positive, and sin theta is opposite side by hypotenuse, that is 4 by 5. So, this 2 0 lies on x-axis. Coming to the 2D geometry, let us say this is 2 comma 0. This is origin, and half comma 2. So this is approximately x value half, y value 2. So this is okay. This point is half comma 2. So definitely this straight line makes an angle theta, obtuse angle, that is lies in the second quadrant more than 90 degrees. Okay. Positive x-axis. Okay, this is x-axis and y-axis. So here theta belongs to second quadrant. So cap is equal to unit vector in the direction of straight line. ST means straight line. This straight line makes angle theta with positive x-axis. So along that straight line, I can take the unit vector as cos theta I cap plus sin theta j cap. Very, very important problem. That means minus 3 by 5 I cap plus 4 by 5 j cap. So this length of this vector definitely is 1. Therefore, required REQ means required directional derivative. Required directional derivative is E cap dot del F. So this is equal to, this is your E cap and this is your del F. Dot product. Sum of the products of the corresponding elements. So 1 into minus 3 by 5 is minus 3 by 5 plus 2 into 4 by 5 is 8 by 5. So this simplifies to 1. So the answer is 1. This is end of the question. The question is the smallest eigenvalues and the corresponding eigenvector of the matrix 2, minus 2, minus 1, 6, 2 by 2 matrix respectively are 4 options ABCD given. This question is from engineering management from the topic linear algebra, subtopic eigenvalues, eigenvectors. Let us denote the 2 by 2 matrix by A. This is 2 cross 2 square matrix. 2 eigenvalues. Smallest eigenvalue. Solution First step, the characteristic equation. CH means character, EQ means equation of the matrix A is determinant A minus lambda I, that is subtract lambda from the diagonal elements only without writing identity matrix. So this will be giving 2 minus lambda minus 2 minus 1 minus lambda equal to G, which implies 2 minus lambda into 6 minus lambda, 2 by 2 determinant expansion AD minus BC, that is ABCD 2 by 2 matrix, minus 2 in minus of minus 2 into minus 1 is minus 2 equal to 0. This simplifies to lambda square minus 6 lambda minus 2 lambda simplifies to minus 8 lambda. 2 into 6, 12 minus 2 plus 10. Minus 8 lambda can be written as minus 10 lambda plus 2 lambda. Okay. So, but 10 into 2 is minus 20, that is minus 10 into 2, but we should get to 10. So, there is no integer factors here. Excuse me. Better to go by quadratic equation for finding that lambda values roots of this second degree equation. So, lambda is equal to minus b plus or minus root over b square, that is 64 minus 4ac, that is minus 4 into 1 into 10 minus 40 divided by 2 into 8, 2. 64 minus 40 means 16, 16, that is 24. So 24 can be written as 4 into 6 from square root 4 becomes 2, 2 root 6 divided by 2. 2 is common from the numerator and cancel the denominator 2. So therefore, lambda values will be getting 4 plus root 6 and 4 minus root 6 are the eigen values of the given 2 by 2 matrix. So this is smallest eigenvalue, 4 minus root 6. Okay. This is smallest E value. E value means eigenvalue. So procedure for finding eigenvector. So eigenvector for lambda is equal to 4 minus root. Okay. So that is a side heading. What is the procedure for eigenvector A minus lambda into capital I, bracket close, into capital X equal to 0. A minus lambda I into I into capital X equal to 0. What is this capital X? Which is a column vector containing two variables. So this is matrix. Subtract lambda from the diagonal elements only. That is subtract 4 minus root 6. So you will be getting it is better all options given in decimal representation. So 4 minus root 6 value, 4 value 2, root 6 value, root 9 value 3. So it is lies between root 6 value, lies between 2 and 3. So lambda value, this value 1.55 after simplifying into decimal representation. This is 6.45. So subtract now 1.55 from the diagonal elements of the 2 by 2 matrix only. So 2 minus 1.55, which becomes 0.45, because this 4 minus root 6 value is 1.55 and minus 2 minus 1, and this is 4.45. The capital X is a column vector with two variables x and y equal to 0. Convert it to equation. First row into this column, which is giving a one equation x and y. Second row into this column, which is giving another equation x and y. Let us check whether two coincident or not. 0.45 into x minus 2y is equal to 0, and minus x plus 4.45 into y is equal to 0. Okay, so definitely these two equations are same. Why? Because if I divide by 0.45, that is 2 by 0.45, you will be getting definitely 4.45. Okay, so you can cross check. 0.45 is 45 by 100. So 200 by 45. 45 in 200 is approximately 4 times 180. Okay, like that. So both coincident or coincide equation. Now the first equation 0.45 into x minus 2y is equal to 0 can be written as x divided by 2 is equal to y divided by 0.4. So directly you will be getting x value 2, y value 0.45. So for one value of lambda, we will be getting infinitely many solutions caplex. Such a caplex is eigenvector. Okay. So this is caplex is E vector. E vector means eigenvector. That is for single eigenvalue, we have infinitely many eigenvectors. One of the eigenvector is simplest form. So I can write therefore E vector for lambda is equal to 4 minus root 6 is nothing but here 1.55 is capital X is equal to small x value 2, small y value 0.4. Is there any option? That is 2 can written as decimal number 2.00. So the answer is 2.00, 0.45. So smallest eigenvalue 1.55. So that is this one and this one. Where it is happening in the options, which option we have like this? So option B. So the answer is option B. This is the end of the question. The question is, if k is a constant, comma, the general solution of dy by dx is equal to y by x is equal to 1. It is a typing error. I will modify it. It will be in the form of 4 options A, B, C, D given. This question is from engineering mathematics from the topic differential equations and subtopic first order equations. Here dy by dx having power dy by dx having power 1. So this is the first order and first degree differential equation. So here dy by dx, this is minus, not plus, is modified. So the differential equation is dy by dx minus y by x is equal to 1. The solution is, this is a GATE 2021 question, DE. So such a first order and first degree equations, almost all such equations can be solved by either variable separable method or linear equation method or Bernoulli equation method or exact equation method. But here it is not. It cannot be expressed as variable separable form. That is y dy terms at one place, x dx terms at another place. Let us check linear equation. Here y power 1, no other y variable term, and y dy by dx are not multiplying. So we can say this is a first order linear equation by rearranging into standard form, that is dy by dx plus p into y. That p is obtained by taking minus 1 by x into the bracket outside into y is equal to q. So this is p minus 1 by x and this one is q. Here constant p comma q are functions of x or maybe constants. Is a first order linear equation in y variable. So the solution variable here y. Now the next step to solve to find the solution is if, that is integrating factor, e power integral p dx. 1 by x integration is with respect to x log x. So e power minus log x. This can be e to the power log of x to the power minus 1 to eliminate e and logarithm which are contradict each other. So which will be giving 1 by x. Since e to the power log of any term, any x term, any y term or constant will be giving fx except 1. Even if 1 e power log 1 0 e power 0 1, you will be getting the same term, constant or any term. So therefore general solution of equation 1, this is equation 1, given equation is y into if is equal to integral q into if integrating with respect to x, that is dx plus, because it is linear equation in y variable. Okay, so this becomes y into 1 by x, that is y by x is equal to right side q value 1 1 into 1 by x dx plus 1 by x integration with respect to x is log x plus So your solution is expressed in the form of y. Y is equal to, I can write x log x. If I take instead of normal constant, that is log c, you can add log c or c minus c depending on the situation of the solution, that is depending on the options. They are all options containing the right side log term. So instead of c, I can take some log of constant log k, so that depending on the options we have to modify, okay, the constant c. So this can be written as y by x is equal to right side log x, no change, plus c can be written as, that is here. Can I take log constant? So that why should we take, that is using properties of logarithm, this becomes log m plus log n is log mn. So this is log of k into x, because all options we observe k is a term there. So finally this can be expressed as y is equal to x times log of kx. So is the required solution? Accordingly, the option is A. This is the end of the question. The question is numerically integrate f of x is equal to 10x minus 20x square from lower limit a is equal to 0 to upper limit b is equal to 0.5. Use trapezoidal rule with 5 equal subintervals. The value in units round up to 2 decimal places obtained is. This question is from engineering mathematics, from the topic numerical method, subtopic numerical integration, trapezoidal rule. The solution is get 2021. So integrand is given 10x minus 20x square, a value lower limit, b value upper limit mentioned, trapezoidal rule mentioned, n value 5 subintervals, subdivisions, 2 decimal places. So these are the main terminology. So first n is equal to 5 implies formula for h is length of each subinterval b minus a by n. So 0.5 divided by 5, which is equal to 0.5, 0.1, sorry, is length of each subinterval. That is after dividing closed interval AB into n equal parts. Now calculating the ordinates y1, y2, y0, etc. Function values. This is function value at A. A is lower limit 0. So 10 into 0 minus 20 into 0, 0. Y1 is function value f of A plus h. This becomes 0.1. So this is 10 into 0.1 minus 20 into 0.1 whole square is 0.01. So please calculate. So this is 1 minus etc. You please check 1 minus 0.2. This simplifies to 0.8 by 1. Function value at a plus h. A plus h value, that is a plus 2h. So this y1 already calculated, y2, kindly excuse me, y2. Y2 is equal to f of a plus 2h. A plus 2h value becomes 0.2. So 10 into 0.2 minus 20 into 0.2 whole square is 0.04. Please check. So this simplifies to 1.2, that is 2 minus 0.8. Y3 is equal to function value at a plus 3h. A plus 3h value simplifies to 0.3. So this is 10 into 0.3 minus 20 into 0.3 whole square is 0.09. So this simplifies to 3 minus 1.8, 1.2. So this is also simplifies to 1.2. Please check. Y4 value, that is function value at a plus 4h. N value 4 means 5 data points. So y0 to y4 means 5 values. So this is okay 0.5. n value 5 means 6 y values we should calculate. N value 4 means 5 y values we should calculate. Still we are not in upper limit 0.5. So this is 10 into 0.4 minus 20 into 0.4 whole square, that is 1.6. So this simplifies to 4 minus 3.2, 0.8. Finally y5. This is also denoted by in conceptual part by n f of a plus nh, that is a plus 5h, which is upper limit. This is 0.5. So this is 10 into 0.5 minus 20 into 0.5 whole square is 0.25. So this is, kindly excuse me, 0.5 whole square is 0.16. This is 0.16. So this is 5 minus 5 simplifies to 0. Therefore, by trapezoidal rule, comma, uh, integral 0 to 0.5 f of x dx is equal to h by 2 into y naught plus yn, sum of the extreme n values of y's extreme ordinate values y naught plus y5, remaining y values multiplied by 2, that is 2 into sum of the remaining y values, 2 into y1 plus y2 plus y3 plus y4. So this is h value 0.1, 1 by 10 I can write, so 0.1 by 2 into y naught 0.8 plus y5 0 plus 2 into y1 value, y naught is also 0, 2 into y1 is 0.8 plus y2 is 1.2 plus y3 is 1.2, y4 is 0.8. So please calculate 1.2, 1.2, 0.4, 0.8, 0.8, 1.6, 2.4, 1.6 is 4, 2 into 4, 8, 8 by 2, 4, 4 into 0.1 is simplifies to 0.4. So the answer is 0.4. This is end of the question. The question is the unit normal vector to the surface x square plus y square plus z square minus 48 is equal to 0 at the point 4, 4, 4 is. 4 options ABCD given. This question is from engineering mathematics, from the topic calculus, subtopic vector calculus, normal vector. The solution is, so this is GATE 2021, unit normal vector surface. Equation let us denote by phi. Let phi is equal to x square. I can write small variable, that is lower class letter, or no problem, upper class letter, minus 48 equal to 0. B, the surface, given surface. Here it is a spherical surface, center 0, 0, radius is root 48. So find del phi. Gradient geometrical represents normal to the given surface, normal vector. This is normal vector. For three variables, I cap, dou phi by dou x plus j cap, dou phi by dou y plus k cap, dou phi by dou. So this is equal to partial derivative with respect to x is x square derivative to x, y z becomes 0. Partial derivative with respect to y is x z becomes constant, that is 0. Y square derivative to y. Partial derivative with respect to z is x y constant becomes 0. Z square derivative to z. And substituting at the point 4, 4, 4, x, y, z all are equal to 4. So 2 into 4, 8 I cap. Similarly, 8 j cap plus 8 k cap. Now, magnitude of del phi, that is length of this unit normal vector, is equal to square root of 8 square plus 8 square plus 8 square, or before that I can take 8 common, We'll be getting 8 times root 3. So therefore, unit, here it is not mentioned outward unit normal vector, inward unit normal vector, and all options are not in plus or minus form. So all are in the plus quantity. I can take unit normal vector is usually denoted by n cap, and the answer is del phi. So the question here, it is indicating according to the options external or outward unit normal vector mod del phi. So this is nothing but 1 by root 3 into I cap plus j cap. So here 8 is common, cancel with this 8 plus k cap. So this three-dimensional vector, that is can be written as 3D geometry 1 by root 3, 1 by root 3, 1 by root. Okay. So this is the answer 1 by root 3, 1 by root 3, 1 by root 3. Accordingly, the option is D. This is end of the question. The question is, if A is a square matrix, then orthogonality property mandates. 4 options A, B, C, D given. This question is from engineering mathematics from the topic linear algebra subtopic basics. The solution is A is orthogonality property means automatically A is orthogonal matrix. Which implies A into A transpose is equal to I is equal to A transpose into A, or this can also be expressed as A transpose is equal to A. So see that options. So I is equal to, this is A transpose into A. The superscript T is nothing but transpose. So which option is there? Closest option, that is A into A transpose is equal to I. So this is the answer. So the answer is A into A transpose is equal to I. I is the corresponding identity matrix. Accordingly, the option is C. This is the end of the question. The question is, the value round off to one decimal place of integral minus 1 to 1 x into e to the power mod x dx is. This question is from engineering mathematics from the topic calculus, subtopic integration. Solution is get 2021 question. So one decimal place, integral minus 1 to 1 x times e to the power minus mod x dx. So let us denote this integration function. Whenever we are having the limits minus a to a, it is better to compare the given integrand by f of x and check whether it is even or odd, so that we can get answer easily and saving the time also. So here, since what is the procedure for even odd function, put x is equal to minus x in the integrand f of x. If you get minus into fx, that is odd function. If you get plus fx, that is even function. So minus x into e to the power minus mod minus x. Mod minus x is mod x1. So minus x times e to the power minus mod x. So this is nothing but fx. So minus f1. So this is now odd function. When the integrand f of x is odd function, answer is 0. Since definite integral properties minus a to a f of x dx is equal to 0 if f of x is odd function is equal to 2 times 0 to a f of x dx if f of x is even function. So the answer is 0. This is the end of the question.